welcome back to 5 Minutes of Math. This is Mr. Lunsford and I'm glad you joined me this evening. Tonight's homework is for the evening of May 18th, 2018. Our topic tonight is math and critical thinking, and this is part of our enrichment series. So let's go ahead and get started. Now, this is going to include a set of two problems where your best strategy is going to be to draw a picture of some sort and think it out. All right, so we're using critical thinking tonight. So here's our first problem. 1/3 of a bridge support is underground. Another 1/6 of it is covered by water, and 325 feet are out of the water. What is the total height of the bridge support? Now, it looks as though we don't have enough information to solve the problem, but we do. So let's draw a picture. So here's our bridge support. This is the ground. This is the water, so this could be the Elizabeth River or the James River, and that part up at the top is the road. Okay, so this is a far off view of what a bridge support actually does look like. All right, so let's take a closer look at this problem. The ground is 1/3 of our total. The water is 1/6 of our total, and we know that there's about 325 feet sitting out of the water. So what's the total height of the bridge? All right, let's think it through. First, let's put this problem in perspective. Let's make ourselves some space, and let's actually divide this into thirds. So we know 1/3 of this bridge is underground, 1/6 of it is sitting in the water, and 325 feet of this thing is sitting out of the water. All right, so the next step we're going to do, 1/3 is the same as 2/6, and just for fun, I'm going to convert my 1/3 to 2/6. It's the same fraction, I'm just changing my denominator so that everything is the same. So that's going to make it a little bit easier. Now, the next step I'm going to take is to think it through. We have 325 feet plus 1/6 of the total plus 2/6 of the total equals the total height. So this isn't an equation, this is just a way of looking at the entire bridge. All right, and so don't think of it as an equation, think of it more as, okay, this is the way we're gonna kind of take a look at this thing. All right, so now I'm going to combine my fractions. All right, so 1/6 plus 2/6 is going to give me 3/6. So 325 plus 3/6 of the total height is going to give me the total height. Okay, bear with me. 325 plus half of the total, because 3/6 is the same as 1/2, right? 325 plus half of the total is going to give me my total height. This is where we start to do some reasoning. Yes, I could turn this into an equation and work it out mathematically, but I want to show you all the reasoning side of this. If we know that 2/2 of a whole are the same size, and we know this from first grade and kindergarten, if you take an apple and divide it in half, 2/2 equal a whole, and if you split it right down the middle, both halves are the same size. If we accept that, then the next part of this should be a simple matter of thinking about it. If 325 feet plus quote unquote the other half of the total height equals the entire bridge support, then the first half has to be 325 feet. Now remember what I said, both halves have to be the same size in order for it to be a half. If you have 10, then half of 10 has to be 5. It's not going to be 4, it's not going to be 3. Half of 10 has to be 5, so that means the other half has to be 5. And in the same way, if half of this bridge support is 325 feet, that means the other half has to be 325 feet. So all we do is multiply by 2. 2 times 325 is 650 feet. Okay, now later on in algebra they might ask you to go back and figure out, okay, what part of the bridge is in the water, and you just multiply that by 1/6, and what part of the bridge is underground, and you go back and multiply by 1/3. But you can figure this out if you reason it out. Okay, so the answer for this one is 650 feet. Okay, all right, let's move on to the next part of this thing. Oh, by the way, it's drawing it out and thinking it through. All right, it's and thinking it through. The next piece of this, Federico is playing a game with his little sister that requires him to arrange cards face down into an array of columns and rows. When he puts 4 cards in each row, he has 3 left over. When he puts 5 cards in each row, he has 1 left over. Give 2 possible numbers of cards Federico might have. Okay, let me explain what he's got. This is a guy who has not discovered Fortnite, and he has a deck of cards with a certain number of cards in it. He can arrange them in one of 2 ways. He can either set them in 4 per row, and if he sets them in 4 per row, he's always going to have 3 left over. He can also take that same number of cards and put them in 5 cards per row and always have 1 left over. We need 2 different size decks that he might have. So in other words, what's a deck with a certain number of cards that could give you both situations at the exact same time? Okay, sounds like an impossible problem, but it's not. And you guys have done this, believe it or not. The foundation for this was in kindergarten and 1st grade. Okay, so let's see what we're talking about here. 4 per row plus 3 left over. I'm going to create 2 different charts in the middle here, the total cards for situation 1 and the total cards for situation 2. Situation 1 is where we set our cards up in 4 per row and we have 3 left over. Situation 2 is where we divide our cards into 5 cards per row with 1 left over. We're looking for the totals to be the same in both situations. Okay, now let's go through a couple of test situations. We have 4 per row with 3 left over. If we just do what we see here, that's 4 plus 3, that's 7. All right, that's our first situation. So we look on the other side, we notice, okay, we have 5 plus 1. That's 6 cards. So we know that he doesn't have 7 cards in a deck. We know he doesn't have 6 cards in a deck. So that's not a match. But let's look at the second situation. If I have 8 cards plus 3 left over, then I'm looking at 11 total cards. And remember, this isn't a function table. This is more of a comparison. We're drawing it out. So don't think about functions and y and x and everything. Look at this as it appears. So we have a total of 8 cards in our first situation. 11 cards in our first situation, 8 plus 3. In our situation 2, if we add another 5, we have 5 plus 5 plus 1. That's 10 plus 1, that's 11. We have a match. So his deck could contain 11 cards because he could set them out in 2 rows of 4 plus 3 or 2 rows of 5 plus 1. So that's a match. His deck could have 11 cards. But let's see if we can find another deck that's a little bit bigger to give him that same combination. All right, let's go on. So if I add another set of 4 cards with 3 left over, 4 times 3 is 12, plus 3 is 15. And on the other side, if I add another 5 with 1 left over, I get 16 cards. 15 and 16 are not the same number, so let's go on. Before I go on, let me mention the matches don't have to be in the same row. Okay, they don't have to be at the same time we're setting them down. Okay, so the matches could be in different rows. What we're looking for are 2 numbers that match each other. All right, so we know 15 and 16 don't match. Here's another 4, so 4, 8, 12, 16 plus 3 is 19. If we add another 5 over here, we have 21 cards. 19 and 21 are not the same number, so that's not a match. We have 4, 8, 12, 16, 20. We have 23 cards here. We have over here on the other side 26 cards if we add another 5 with 1 left over. And also not a match. Let's add another 4. We add another 4 with 3 left over. We end up with 27. 6 rows of 4 and 3 left over, 27. Over here in situation 2, if I add another 5, that's 6 times 5 is 30 with 1 left over. That's 31 cards, also not a match. However, let's go on and add another 4 cards here. We have another 4, and that's 7 rows of 4. That's 28 total cards, plus those 3, 31. And look at what we have here. We have another situation, another deck where he could create this particular scenario where you have cards organized 4 per row with 3 left over or 5 per row with 1 left over. That deck could be 31 cards. Okay, now if you keep processing this, you'll find out that he could have a deck with 51 cards in it. He could have a deck with 71 cards in it. He could have a deck with 91 cards in it. All of those work. And now, if you go to the math side of this and you want to work it out, oh, by the way, yes, the answer that you can use for this, 11 or 31. Is there an easier way? Because you're like, I don't have time on an SOL test to go scribbling through and drawing cards and everything. There is an easier way. But you're going to need to know some things that, like least common multiple, common difference, arithmetic sequence. Thankfully, you're going to get to all of that in algebra. So you have some stuff to look forward to. All right, and that's it. Y'all take care, and remember, math is not just about numbers. It's all about the relationships that surround us every day. Have a good one.